Now that we can identify the oxidation number on any atom in a given substance or species, the next thing that we want to do is to look at how do we balance oxidation reduction reactions. And this is a little more complex than just our normal balancing that we've probably been used to, because now we have to account for electrons. So it's not just enough to have a mass balance where we have the same number of atoms of each element on each side. We also need to account for the fact that electrons are involved in our reactions. And so we need to make sure that if I'm losing two reactions on one or two electrons on one side, that I have that accounted for on the other side as well. So in this first example, so we're going to look at a net ionic equation. So I have copper solid plus an aqueous silver ion going to a copper ion plus my silver. And the first thing that we always want to do when we're going to balance an oxidation reduction reaction is to identify the oxidation number for the atoms we're interested in. So in this case, we're going to identify oxidation numbers for each species here. And this one's pretty straightforward. So remember that first rule was anything in its natural state has an oxidation number of 0. So any metal in its natural state is going to have oxidation number of 0. And I just like to write these right above my reaction. So that copper is 0 and also that silver is 0, right? They're both in just metals in their natural state. Then if we have monatomic ions, we're going to use that charge. So my silver here, this is going to be a +1, and my copper here is going to be a +2. So first thing is just identify your oxidation numbers for each of your atoms. Then we want to determine which species is undergoing reduction and which is undergoing oxidation. So remember, if we remember our little Leo says grr, right? So loss of electrons is oxidation, gain of electrons is reduction. So the thing in this reaction that is losing electrons is the copper. So the copper is involved in the oxidation piece of this. We're going to split this into the oxidation and reduction piece. So the oxidation half reaction is going to involve my copper. And then the reduction, remember reduction is gaining electrons, or you can think of it as reducing that oxidation number, right? So if I'm gaining electrons, that oxidation number is going down, it's becoming more negative. So in every redox reaction, we're going to have two half reactions. We have the oxidation piece and we have the reduction piece. And so we identify oxidation numbers, then we identify which half of that reaction or which species is doing the oxidation part and which is the reduction. So the reduction is the silver. So I'm going to write the silver. We're going to split this into our half reactions. So I've got silver here, and that silver goes to silver solid. And my copper, this is my oxidation. So I've got copper plus, not copper plus, copper goes to our copper ion, aqueous. Okay, so that's our next step. Then we want to add in our electrons, right? So we're going to actually include these in our reaction. So for the first one, for that silver is going to gain electrons. So I must add an electron to this side. So I'm going to add 1 electron to that reduction half reaction. And then if I look at the copper is going from copper solid to copper ion. So it must be generating or losing or producing 2 electrons so that I end up with that 2 positive charge on the copper ion. So we do oxidation numbers, separate into oxidation reaction half reactions, add in our electrons. And then what we want to do to balance it is we're going to add these 2 reactions back together. So we split them up, plug in our electrons, and then we're going to put them back together. When we put them back together, we need to make sure that we have a balance of electrons on each side. So if I'm taking my reduction reaction, if I'm adding 1 electron, I can only need 1 electron or produce 1 electron in that oxidation reaction. So I need to have these electrons equal for the 2 half reactions. If they are not, we're just going to make it so they are. So we're going to double that first reaction, just multiply everything across the board by 2. And when I do that, I will be reacting two of those electrons. They'll join with my silver ions. I'll be using up both of these electrons, right? So I won't have any just leftover electrons floating around once I add these back together. So then our balanced equation, when we add these all back together, so I'm going to just, for this time, I'm going to write out all the pieces. So I have two electrons, I have two silver ions, and then I have a copper solid. I'll go ahead and put the solid and the aqueous in there. And then on the product side, I have two silver solids, I have a copper ion, and I have these two electrons. So I like to write this out, and I don't know why I made this a little positive over here. So these are my electrons. I like to put my electrons on the outside so I can just kind of cancel those out, right? And I like to have them in there to make sure that I did everything right. And then what we have left over, this then is our balanced equation. So the equation, if you look compared to what we started with, it is a little bit different. So in the first one, I just had coefficients of 1 across the board. But by looking at those electrons, looking at the oxidation numbers, I realized for this to actually be balanced, I'm going to have two silver ions for every one copper atom in this reaction for it to be balanced. So this would be our final balanced equation. All right, I'm going to work through another example. So we're going to go through just more quickly, but do the exact same steps. So here we have aluminum reacting with a hydrogen ion to give us an aluminum ion plus some hydrogen gas. So we're looking for the balanced equations for half reaction and then the overall balanced equation. So I start with oxidation number. So anything that is an element in its natural state is just 0. I always like to go in and do those first. And then I have just ions left over. So this is 3, and this is going to be 1. So I have my two species. The next thing I want to do is look at what's reduced and what is oxidized. So in sticking with, I think I did the orange for the thing that was reduced. So I have hydrogen, my oxidation number goes down. So it's going to be a thing that's gaining electrons, and that's our reduction half reaction. So I'm going to go ahead and write that here. Goes to my hydrogen gas. And then our aluminum is going to lose electrons, right? It's going to break down, or it's going to react into the ion plus electrons. So we're going to put our aluminum is the oxidation half reaction. Okay, and then next step is to add on our ions. So in the oxidation piece, in the oxidation half reaction, electrons are going to show up on the product side, and I need to have 3 because to form that 3 positive aluminum ion, I'm going to produce 3 electrons. And then for my hydrogen piece, I'm going to have actually 2 electrons. So I skipped one step, so I'm glad I did this example so I can do that. Once we separate out those, the 2 half reactions, so I'll pull back on this in just a sec, we do want to balance by mass first. So I should have run through before I added those electrons and made sure that I had a mass balance on each side. So for that oxidation reaction, I have 1 aluminum atom, so that's in good shape. But if I look at the reduction, I have 1 hydrogen ion on one side and I have 2 hydrogen atoms on the other side. So I first need to balance the balance for mass, and then I can go in and add my electrons. So for that hydrogen piece, I need to add 2 electrons because I have 2 hydrogen ions and each of them is going to take 1 electron. So 2 electrons added to the hydrogen ions is going to give me that 1 molecule of hydrogen gas. So I've got my oxidation numbers, my 2 half reactions, balance for mass, balance for charge. Now I want to add them back together. And I need to do that quick check. Do my electrons match, right? Here I've got 2 and here I've got 3. So they don't match. We need to make them match. So the way we're going to make this one match, we're going to multiply that top one by 3. We're going to multiply that bottom one by 2. And then go ahead and again, I'm going to write out all the species. So in the total, I've got 6 electrons plus 6 hydrogen ions. And then I've got 2 aluminums. And then on the product side, I'm going to have 3 hydrogen molecules plus 2 aluminum ions. And I've got that additional 6 electrons here at the end. So because I wrote my electrons all on the end, I can go ahead and cancel those. And then I'm just going to kind of chunk out what's left here in the middle. So this is our balanced equation that is balanced now for both mass and charge.